that I was attending this event. There's an event that is happening here. I don't know if you're aware of these kind of activities that happen in the university. So the university is but why is this thing not working? Who cares? So university, through the Center for Information and Communication Technology, CICT, has organized this is a marathon kind of workshop, right, where they're orienting staff on AI and stuff. And you know, I must tell you this. I used your class as an example. You know, I was right there in the thick of things here. I was right there. At some point, I had you as an example. You know, I don't know what this is here, but I was using you guys as an example. What is that? I have a whole slide about you guys. Of course, I mean, for ethical reasons, I masked out your details. You see this? I was using this as an example. You know, but anyway, I thought I would mention that. So apologies that I came late here, but I want to continue this discussion. We want to wrap up this discussion of lectures. I want to call this a module, really, to be honest, because we've spent quite a bit of time doing this. And incidentally, I think it's the part where I tell you to say, I will be reaching out to Prosapiri and Prosapiri and Dr. Nyirenda so that we can agree on when exactly I'm supposed to hand over to them. You know, if you remember, I'm co-teaching these calls with the two of them. You know, so there's that. But we're going to continue this discussion for now. We're going to continue this discussion right away, right? And we are getting coming from a stage really where we were I think we're discussing, you know, the phases, the 5 phases of CRISP-TM methodology. Here's to hoping you guys understand. I have shared, excuse me, a notebook. Sorry, I don't know why I'm all over the place here. Mr. Hudson, are you around, sir? I don't know if there's too many.
Yes, I am.
Ah, beautiful. I'm so sorry, Hudson. You know, I'm so sorry. I literally forgot that I was supposed to introduce you. Now, ladies and gentlemen, I sent an email introducing the tutor, Hudson Matakala. Usually when, I know this is like 12 August here, there's exactly 1 month left, but, you know, it's supposed to be around to help us go through the tutorial notebooks. In fact, I'm going to expand on those things here so that we understand what needs to be done. And more importantly, I'm supposed to interact with him. I want him to focus a bit more on trying to help you work towards your respective group-based projects, you know. But Hudson, I'm going to hand over to you here. I think a little bit of an introduction would help. Usually what happens at the UNZA is people are recycled. There's inbreeding, right? I guess I'm an exception, I don't know. Where the same people that went through a department are the ones that are tutors, they're the ones that teach. Everybody in that department of yours went through the UNZA. I don't know if you know this. Dr. Lampi, I don't know if he teaches you, was my supervisor for my capstone project report. Back then he was in the Department of Physics. He was doing electronic stuff before he formally moved to the department. That was in 2000, and I worked with him in 2006 and part of 2007 before I graduated. Actually 2006 because I graduated in 2007. You know, yes, Paul, I'm a dinosaur here. Everybody, Dr. Nyirenda went to the department, you know, Prosapiri, it's everybody, right? This is what happens usually. So Hudson went through the department. Hudson, I'm going to hand over to you here. Maybe a bit of an introduction, who you are, you know, what you've been up to when you graduated, and what's going on with you. Are you tutoring any other courses? But I'm going to hand over to you. Thank you. I think you're muted.
Everyone, are you able to get
There we
me?
go. I can hear you now.
Right. This is Matakala Hudson. I just graduated recently, a few months ago. So just like everyone else, with Dr. P here being an exception, we've all been through the department. And currently I'm a tutor, a part-time tutor in how many courses, let's say. That's software engineering, advanced software engineering, quality assurance, and now data mining since my co-tutor has been quite busy. So in the meantime, I've been asked to step in and see how we can fuse these things together and see how we can help each other out because there's quite a breakdown on stuff and the like. So I think that's that. I don't know what more
Oh yes,
information I have to
yeah,
share.
that's no, that's that, Hudson. Thank you very much. But you forgot. By the way, just a correction here. I was in the department between 2000 and I was in NS in 2003. I was in the department back then. There was nothing like direct entry here. You had to compete for slots. Things have evolved here. During my time here, there was a quota. You could only have no more than 15 people in the program itself. And so I remember my class was a class of like 12 people or something. So I went, I was in NS in 2003 doing these generic courses, right? Physics, chemistry, biology. I hated biology. And then in 2004, I went to the, then the department, it was computer science department, computer studies, actually, it used to be called. So I was there between 2004 all the way up to 2007 when I graduated. But you forgot something very important here, right? The plan, the tutorial plan here. I don't know if you finalize this. Is there something you want to say? If you haven't finalized, maybe by when? I'm sure that these guys are anticipating, eagerly anticipating for these sessions to start.
All right. For the tutorial plan for data mining, we're still juggling around. But for now, I reached out to one of the class reps, and the conclusion was to say, is it Thursday from 9 to 9:50? There's a slot on the timetable. Is it on Siwela lecture hall? I hear you usually have your lectures, physical lectures, around 11 hours on Thursday. Since Tuesday, we have a clash with the FDA course. Then I'll later reach out to you for the breakdown and what I have to work with so that we can pick it up from there.
Wonderful, thank you. I hope we can start this Thursday. I'm really, really keen, and I'm going to ask that we have a meeting maybe tomorrow to sort out these last-minute issues here. So thank you so much. If you want to join class, that's fine. If not, we'll see you. By the way, on Thursday, we have an in-class quiz. So I'll need you to be around. Please reach out to me in the event that you're not available. The quiz is going to be probably just 10 minutes, not more than 10 minutes. So I need somebody to help keep an eye out for people that cheat, mostly. So just 10 minutes, the first 10 minutes. We have class on Thursday between, we're supposed to have the quiz between 10 and 10:10, or let's say 10 and 10:15. Sorry, 11 hours and 11:15. If you can't, please shoot me an email, but we'll be expecting you there. So thank you so much, Hudson. Really appreciate this. Unless if maybe there's a question from the students before you leave. Any thoughts about this? Okay, if not, my style is simple. I'll be sending through tutorial questions that Hudson is going to be interacting with you guys. Yes, Victor.
My question was, what email should I reach out to you with? Should I use the Google Groups or something else? The email address.
Whatever works for you. If it's something of a personal nature, you don't want the others to know, you can send to lighton.peri@unza.zm. If it's something that, because usually these queries would be of benefit to your colleagues, so generally it's a lot easier if you just send it to CSC4792@unza.zm so that everybody receives the email. In fact, if you've noticed, what I do sometimes when I'm responding to you, right? I'll respond to others so that they see my response and hopefully pick up on one or two things. Okay. I don't think there's any other question. Thanks for Hudson. So I think we're done. Thanks, Hudson. So we're going to continue here, colleagues, ladies and gentlemen. I was just mentioning that I shared with you guys. The don't know why this recording is not taking place, but that's fine. I shared with you guys, I was making mention of the fact that I shared this is so silly, this thing. I have no idea why this is not, yeah, maybe ready. So I shared, I believe I shared a notebook on data preparation. Now, something worth mentioning about that notebook is, and I think I hinted at this, right? I may mention the fact that that thing only includes, very basic things, right? We are supposed to have, or depending on whether it's Professor Piri or Dr. Nyirenda who's going to be teaching that here, but it's supposed to be a dedicated session on preprocessing and transformation, because if you've noticed, we've introduced, if you've paid particular attention to the notebook, which I've shared with all of you, you'll have noticed that we subtly introduced some new packages. The import statements, if you noticed, we've primarily been using pandas, and I've tried as much as possible for the examples I've been using to restrict myself to pandas where applicable. But you notice that we snuck in things like NumPy, and more importantly, sklearn. This is a scikit-learn package. In fact, the sklearn package or scikit-learn is where this is the package we're using to vectorize the text. You remember the backwards model? This is a package. You don't do this from scratch, although when we cover this, you are probably going to go through a process where there's a demonstration that showcases exactly how this thing works. Like, so a simple heuristic. How exactly do you come up with that? That's one thing. And then something else I snuck in is the natural language toolkit package, NLTK. If you noticed, we're using the NLTK to gain access to the English stop words. So during our detailed preprocessing / transformation lecture, we are going to have a brief introduction to this new package, this new important package, especially sklearn, because this will pop up again when we start looking at model implementation. You know, you use this package to gain access to functions that you use to conduct your effectiveness evaluation, for instance. Anyways, that's neither here nor there. So we're going to continue our discussion of this lecture series. We've done quite a bit. I'm very happy and proud of the fact that we've done this. But listen, we said that according to the syllabus, they've told us that we're supposed to look at KDD. We started off by focusing on the CRISP-DM methodology. But prior to our discussion of the CRISP-DM methodology, there was mention of the fact that there's a slew of other approaches or methodologies that can be employed, right? And in fact, if you remember the poll results from KD Nuggets, there's something really interesting, right, about the sort of methodologies that people use. The fact that the CRISP-DM methodology appears to be one of the most widely used methodologies. Right, but we said that we're going to cover schema and KDD. Why? Well, because the syllabus says we should cover the KDD process and schema, I guess. And also because the KDD process appears to be the root of everything, if you notice. The CRISP-DM methodology traces its roots from the KDD process, right? We did this. Now, in terms of the KDD process, what you begin to notice, if you look at the stages, number one, it may not be intuitive here, but what you begin to notice is that there are striking similarities between these phases or stages of, of the so-called knowledge discovery in databases methodology or KDD, but the phrasing may be different. Your task, if I were you, is trying to do a mapping, right? There's already a mapping, obviously. There's a slide that we discussed at length, but a mapping between the stages from the KDD process and what we have in the CRISP-DM methodology. The mapping I'm talking about, ladies and gentlemen, is, if we were to go back to the earlier slides that we're looking at, where is that? Here. You remember this? This here. Or this. If you decide to use this, the columns will represent the different approaches or methodologies, right? And then the rows or the y-axis is representing the phases. Maybe this is a lot easier. If you notice, there's a mapping here, right? We see that for SEMA, right, the data understanding is aligned with sample stage and explore stage. Data preparation is aligned with SEMA's explore stage and modify stage. Modeling is associated with model and assess. Evaluation is aligned with assess. And we see that there's no equivalent stage in SEMA that can be mapped onto what we introduce as deployment in the CRISP-DM methodology. In addition, there's no stage in SEMA that is aligned with business understanding phase in the CRISP-DM methodology. In fact, if you're trying to justify why I'm going to use the CRISP-DM methodology, you could state that, there's no explicit outline of the deployment or anything that is equivalent to the deployment stage or something like that. Do you understand this? And then maybe I see there's no KDD here equivalent, but because I didn't snip it properly, but if we come here and we look at the detailed KDD process, right? We notice here that pay particular attention to the very first column here and KDD process. There's a mapping, right, between the stages here and the corresponding CRISP-DM methodology stages. This is what you should be paying attention to. Anyways, so I want to go back to, like I said, I promised would skim through SEMA and KDD because the things we are supposed to be discussing are more or less the same activities that were introduced to us when we were looking at the CRISP-DM methodology. So your homework is going to be maybe to try and see if we can come up with a mapping of the activities from the case study here, the ICT 1110 prediction thing when looked at from the perspective of SEMA and the KDD process. Okay. Anyways, so in terms of the KDD process, we see here that the KDD process or knowledge discovery in databases process views knowledge discovery as apparently a linear sequence of steps. Very, very crucial here. We notice that with the CRISP-DM methodology, you can easily loop back in between stages or something. So this is the linear sequence of steps. And so the data mining step is seen as the core algorithm part of the broader process, this stage here. Okay. In terms of the specifics of these different stages, right? 4 of them, 5 of them rather, we see that we first of all have selection. And what you're doing with the selection stage is you're creating the target data set from a large source of raw data. In other words, what you're doing as part of selection is you're identifying where the information is going to come from. Using the source, you harvest or you collect the information, and then you compile this target data set, the data set that you're going to use for eventual implementation of the model. Okay, to a certain extent, you notice here that you may, as part of stage number 1, which is selection, find yourself wanting to understand a bit more about the domain you're working in. So, for instance, if you're implementing an inference model for the banking sector, you'd have to understand the financial sector and how it operates. Okay, and the thinking there is that knowledge will enable you to identify the appropriate attributes. So tables, if you're getting data from the database or something, or files, data files. And then we see that stage number 2 is explicitly tagged as preprocessing/cleaning, right? If you remember in the CRISP-DM methodology, this stage was referred to as data preparation, right? And as part of data preparation, we're talking about things like, transformation, preprocessing, right? But in the case of the KDD knowledge discovery in databases process, we see that we have a dedicated preprocessing stage. In other words, we're solely focused on cleaning the data. The goal is to improve the quality of the data. Yeah. Now we see that the tasks that you are performing, yeah, these are similar to the things that we introduced you to when we were discussing data preparation. You notice this? You're handling missing values. Are you going to impute things like empty strings.
Where
Some,
is my
yeah, I don't know about that. Please mute your microphone, Miss Madam. Are you going to impute the values with a mean, with some default value or something? If it's scores, we impute it with a 0 in our case. Some other things that you do is you're removing noise and outliers. In essence, it's the same things that we introduced as part of data preparation. All right. Interestingly enough, or oddly enough, in the KDD process or methodology, we are separating preprocessing from transformation. Right? So stage 2 is preprocessing or cleaning, and then your stage 3 is transformation. So in other words, the things that we said we do as part of data preparation, like merging of data sets, one-hot encoding, you're transforming these attributes, depending on their types, into numbers. Let's just simply put it simply, numbers, right? So you get your text and you transform them into numeric representation using TF-IDF or continuous bag of words, or perhaps TF-IDF, right? Or using very sophisticated word embeddings, for instance, or text embedding algorithms, right? Anyway, so you're transforming the data. Yeah. You do also do things like scaling here, and you notice explicitly what is being mentioned as part of the KDE process stage 3 here is that you are handling what's called dimensionality reduction. You are trying to reduce the vector that you're going to use as input. And I showed you this when I was transforming the text. I don't know how many of you guys were paying attention, but I told you that when you're working with data like this, we've made it simple here, right? It's like we're saying, well, we are going to have 69 attributes. The data set that I've given you guys, 69 attributes. But in actual fact, when you're implementing the model, you're not feeding it the 69 attributes. No. You're going to feed it more than that. Because guess what? In the case of the text, if we are going to use the motivation piece of string there as input, as a feature, in effect, what we are saying is that besides things like one hot encoded version of gender, one hot encoded version of the minor, we have minor 1, minor 2, minor 3, because they're stringed together like this, is it? Maybe there are 5 minors or something. What else? Sponsorship has got to be one hot encoded, right? We have GRZ, you have 75%, 100%, you have people that I guess they have a wave or something. They are related to a member of staff, maybe their father or their mother, a member of staff or something like that. You want hot encode. Now here's the thing: the text. You have these words, right? The terms. In the case of the example I was giving you, we have 375. So it would be word 1, 2, 3, 4, all the way up to 375. And that's a very small corpus, right? So in other words, you're stringing together, you're working with this input vector. Now, because you're working with this input vector, one of the things you have got to do is make sure that this thing is as small as possible. The larger the input vector, the more compute resources you shall require. Now I know it's not an issue now. Oh, we are going to use my computer which has 32 GB of RAM. Okay, fine. In the event that we don't have a computer that has that much compute resources, we're going to go to Xamarin and we're going to apply for their high performance compute. We're going to apply so that we make use of their high performance compute infrastructure. By virtue of being a student at UNZA, you have access. They have these things. I don't know about them being high performance compute infrastructure here, but you'll be able to run processes that you can't run on your laptop. Okay. So, but the thing is, the obsession here behind dimensionality reduction is you want to ensure that the input vector is as small as possible. Okay, so this is what you do as part of stage number 3 in the KDD process. We see here that there's then a dedicated data mining process. And apparently it's supposed to be the core algorithmic step, right? In other words, this is the part where you're choosing the estimators you're going to be using. We're going to use naive Bayes, or we're going to experiment with naive Bayes and stochastic gradient descent and things like support vector classifiers, and then we'll figure out which one is better, or decision trees, or random forests, or logistic regression, and all those things, right? And interestingly enough, for them, it is in stage number 4 that you choose a specific data mining task. Are you solving a classification problem? In fact, you have to be specific. What type of classification is this? Is it regression? Is it binary classification? Is it multi-class classification? Is it multi-label classification? Or is it unsupervised machine learning? What we discovered in the CRISP-DM methodology is that this thing is done as part of business understanding. So subtle differences, it's almost like you're just shifting around activities. Anyway, after stage number 4, you have stage number 5, where you are interpreting the findings and conducting in-depth evaluation. This is quite interesting. It's almost like there's a one-to-one match here, right? What we have in the CRISP-DM methodology as evaluation is the same as what we have here as interpretation/evaluation. So in terms of the similarities here, we see that obviously stage number 1 is one of those stages that has a one-on-one correspondence, right? Evaluation here matches evaluation in the CRISP-DM methodology. Do you understand this? Simple stuff. You see, your role as a person who would be contracted, and good things will come your way if you're smart here. Very, very soon. It's just a matter of time. In fact, this has already happened, where more and more entities are looking for experts that know how to do these things. If somebody approaches you and they tell you there's this data mining project that we want you to work on, one of the very first things that you have got to tell them is to say, we need to decide on a methodology. We have various options: CRISP-DM, KDD, and SEMA. Up to this point, you should be able to tell them to say, I think we're going to take the approach where we use the knowledge discovery databases process, or the CRISP-DM methodology, or the CRISP-MLQ approach or something, if you get to the stage where you study that stuff. And so pretty straightforward here. So you have a choice of, for now, KDD and CRISP-DM. And if you've been paying attention, you'll be able to justify. Now, there's also SEMA, we said. Now, this is like acronym here for SEMA is sample, explore, modify, model, and assess. In other words, you're just trying to come up with these are acronyms for the different stages. If you look up the SAS Institute, they have a whole host of documentation about SEMA, right? So if you just go online and you just say SAS, SEMA or something, I don't know why I'm even doing this. You know how to do this. You will find detailed documentation about SEMA on the SAS Institute website. So this is an entity that's behind the approach or the methodology. It's marketed as apparently a highly practical and a tool-oriented linear methodology. I don't know about that. Normally, when you come up with your own approach, you want to convert people. So selling becomes important here. You have to be a sales master somehow. I don't know, but if you are paying attention, you notice that CRISP-DM, for instance, is tool agnostic, right? I don't know how much of this you remember. So if you're looking at differences between SEMA and CRISP-DM, already we notice that it's tool-oriented, whereas a CRISP-DM is tool agnostic. Okay. In terms of the specific stages here, by the way, notice here, 5 stages. 5 stages here. The CRISP-DM methodology has 6. Okay. Anyways, so sample, all you're doing is you are selecting a representative subset of your data so that you conduct some very initial modeling. Very, very peculiar here, right? Especially that in both the CRISP-DM methodology and the KDD process, you only get to start your implementation of the models, in the case of the KDD, as part of data mining phase here. And in the case of the CRISP-DM methodology, when you're busy with modeling. However, what these guys are saying is that you get a representative sample, and using that small sample, you do like a preliminary modeling, right, so that you can quickly implement some model, which would be okay because you wouldn't be deploying that model, right? You just doing implementation so that you see how things are going to unfold or something. And then they have a dedicated explore step or stage, which apparently is visual in nature. So in other words, what you're doing here primarily is you're using visualizations, graphs, plots, charts to understand the data properties, the distribution and relationship between the variables. If you are paying attention, what they're talking about here is what we introduce as exploratory data analysis. And in the CRISP-DM methodology, exploratory data analysis initially manifests itself as part of data understanding. Yeah? Data understanding is step number 2 in the CRISP-DM methodology. But what we mentioned as well was that we also find ourselves doing a considerable amount of EDA as part of data preparation. Anyways, and then you have the apparently modify step, where you are cleaning and transforming data and selecting variables, right? So a feature selection is done as part of this. And the cleaning here is code word for pre-processing. Transformation is precisely that. So in other words, if you think about it, right, it's almost like there's a direct mapping between what happens during modify and what happens during data preparation in the CRISP-DM methodology, because we discovered that in the CRISP-DM methodology, as part of data preparation, we pre-process, we transform. The only difference here is the naming, right? This is called modify in the CRISP-DM methodology or approach. It's called data preparation. However, in the KDD process, we have a dedicated pre-processing / cleaning stage and also a dedicated or standalone transformation stage. Yep. It's like, they're all shoes, Crocs and Canvas, and what other shoes do people wear? Oxford, right? I don't know if people pay particular attention to these things here. But after modify, we have a model step where you are applying your preferred estimators or algorithms to the prepared data, right? So that you come up with this inference model or you identify the patterns. Again, you notice here that there's a direct match between what we are calling as the model step and the modeling stage in the CRISP-DM methodology. If we were to compare what's happening here with the KDD process, we notice that in the KDD process, that model step is tied to stage number 4, which is data mining. Simple stuff here. And then you have assess. Assess really is like the way it is, almost like a synonym for evaluate, right? You're evaluating what you've built. You've built the model here. You have got to evaluate it, right? Is it useful? Right? What is the effectiveness of the model? What about the efficiency evaluation? So what you're doing here is you're evaluating the model's performance and usefulness, typically by testing it on different sample data. Again, a correlation here is direct mapping between assess in SEMA is the same as interpretation / evaluation in KDD is exactly the same as, I don't want to go back to the slide, it's exactly the same as what we introduced as evaluation in the CRISP-DM methodology. CRISP-DM is almost the same, right? So evaluation or assess there is the same as what we're calling as evaluation here. 5th stage. Surprise, surprise, no deployment here in SEMA, no deployment in KDD. If you're looking for a reason why. I mean, trivial stuff here. And really maybe if the event that SEMA becomes a bit attractive for you, you know, and I was looking at these different steps here, is the sample, you know, step emphasizes starting with a smaller management Sorry about that. I think my dongle just died. I was somewhere, and these guys, I don't know if I signed a warranty with them, but the battery for this router I purchased a couple of years back, I guess, is not as effective. Sorry about that. It went off, battery died. Anyhow, so we see here that I was just
Can call it the day for today.
sorry about that, everybody. I had a bit of a technical issue there. This is quite unfortunate, this thing. Anyways, so I was just doing a recap here of the SEMA stages here. Assess is where you check how well your model performs, which is pretty straightforward stuff, in my opinion. You notice here, it's very clear. Now, here's what I'm going to say here, right? Nobody, just like software process models, if you remember your software engineering, they'll say, I don't know if you remember how much of this you remember. You have a slew of software process models to choose from. There's a waterfall model, and there's things like the spiral model. There's Kanban. There's Scrum. There's feature-driven development. There's Scrumban, right? Your task is to choose an approach that is fitting for the problem that you're addressing. And because we've discussed all these three different techniques here, it should be fairly straightforward for you to choose. I don't have any questions about SEMA and KDD. Any thoughts about this? Can you hear me, by the way? Okay.
Yes, sir, we can hear you.
Okay, wonderful. Thank you for confirming. Glad you can hear me. I can also hear you. Thanks. Now here's the thing, right? I sat there and I was thinking, when was the best time? Should we have defined what data mining and warehousing is and stuff, or or should we do it now? I thought I would mention this, right? Because it turns out some of these things that we're talking about here, right, can be applied when you're creating these maybe data warehouse, for instance, or a data mart or a data lake, right? Things like preprocessing, which is why we decided to discuss those things beforehand. But just to put it out there, you say when we are having a discussion of so-called data mining, our reference is to the process of trying to identify patterns or correlations, relationships that exist, right? Or maybe insights, driving insights from large data sets. Right? So in other words, what you're looking at doing here is identifying hidden or valuable information. In most instances, most of these things that you're going to be discussing as part of the modeling process, you'll notice they'll be latching onto statistics, right? Things like a regression model, right? We created a regression model that's going to tell us the JCTR BNNB value for December 2025 or something like that. So the goal really is you're turning your raw data into actionable knowledge or something. And then really, when we're talking about warehousing here, we are referring to, this is a process, data mining, but warehousing, a data warehouse really is like an information system that aggregates information from multiple sources. So the goal of data warehousing is to create this single source of truth. It's like UNZA right now. There's information about you in the library, how many books you've borrowed since first year, if you've done that. There's information about you at UNZA clinic, if you've been sick. They have records about you. There's information about you in SIS. Guess what? There's information about you in Moodle. Now, it becomes chaotic if you are wanting to generate, reports by using data coming in from multiple sources. Generally, there are things like inconsistencies or something. So the idea behind data warehousing is you're creating this single source of truth, right? You're designing specifically to support reporting and data analysis requirements. And generally, right, what you begin to notice because of how you're designing this thing, and more on this because there's a dedicated discussion where you're going to be looking at how you design data marts and data lakes and data warehouses, right? You're going to be latching on to concepts introduced to you in relational databases where they'll be teaching you how to create so-called star schemas and all those things. But some of the key characteristics here is it's subject-oriented, right? There's key subjects. So you'll be a data warehouse about students at UNZA, or about lecturers where you find details about Lighton's KPIs, right? Information as it relates to promotions, information as it relates to, I'm trying to think of the different systems that we use, by the way, just to put things into perspective. If somebody wants to find information about me at UNZA, they would have to pull information from, there's an academic promotions tool, right? So the academic promotions tool is what UNZA uses to promote people like me, academic members of staff, right? So they look at how many publications do you have? How many courses have you taught? How many of those courses, postgraduate courses and undergraduate courses? Also, at the beginning of every year, I have to come up with a work plan or something, right? So along with my boss, who is my head of department, I'll sit down with him and then I will come up with a plan. This year, I'm aiming to do these things, right? And then next year at the beginning, I will be evaluated based on my work plan. Say, relative to these things that you said you're going to be doing, how have you performed, right? So I'm appraised by my boss. Now, if you notice, the point I'm trying to put across is there's information in the academic promotions too. There's information in the performance management system. There's information about me in SIS, which courses I teach. There's information about me on Moodle and stuff. Generating reports about what I do becomes problematic, right? Unless if you have this single source of truth. So this data warehouse is subject-oriented, it's integrated. You're pulling information or data from multiple sources. It's time variant, obviously, right? So the data will represent a snapshot, a series of a snapshot over time. So it will be like the data warehouse has information as of 2024. We in my previous life, I think I mentioned that I was a business intelligence analyst for Celtel, Airtel, and Zen or something. Spent some 5 years there. And what we had were data marts about subscribers. A subscriber like you goes online and you're accessing these funny sites or something. Airtel is keeping track of those things, right? Which sites you visited, how many megabytes of data or gigabytes of data you're downloading from those sites. Call details, who you called, which BTS, right? The cell tower you used to connect the phone call, how many minutes you spent. It's nuanced information actually. So what we'll do is we'd actually do reporting because we had to do reports for sales and marketing, right? Marketing will always come up with campaigns or something. Generating information becomes problematic because data for anything to do with browsing at the time, we're using the Jatayu charging proxy. It was being inserted into a completely different database. Data about phone calls was different. In fact, there was a separate database or separate logs for postpaid subscribers and prepaid subscribers. So ultimately, at some point, we had to create these snapshots, right? Where we are pulling information from different sources, and reporting was a lot easier that way. So it's time variant. And then we see that it's non-volatile, right? So you are essentially reporting based on stale data. Typically, it would be, you'd be creating something like a snapshot as of at the month end. Like right now, if we had a data warehouse at the UNZA, we'd be working with a snapshot as of the end of July, which is July 31st. You're not really taking into account the things that are happening right now, in other words. So as data warehousing, you guys are going to have a lot of fun with Presapiri and probably Dr. Nyirenda or something when you start understanding how you design these things, right? You know, I have a story about this, right? I was fresh off the boat here when I joined Celtel. I remember that day here. Oh, of course, I mean, when I graduated, I was an intern when I was a student. So when I was graduating, I already had a job, right? I was still going to this startup. It was called WebCon or something. We used to develop web applications. WebCon died here, right? Typical of startups. But they had contracts with you know, Concoa Copper Mines and stuff. It was big stuff here, and PSMD, right? Government entities. But here's the thing. Immediately after I graduated, an offer with Evelyn Hon, and some I went there and I'm being oriented. This is where we extract data from. I already knew how to go there. The immediate thing I realized was redundancy, right? I'm sitting there and I'm telling my immediate boss, my parent, I'm telling him, get the standard paper in,
We can't hear you, sir.
normal form or something. Oh, you can't hear me? Am I talking to myself? Somebody's saying they can't hear me.
You were breaking, sir.
Oh, okay. Sorry. I was telling a story about. I was telling a story about data warehousing, right? So my orientation to one of the databases, we used to call it the dynamic validity, the DV. Part of what the DV used to do is it would keep track of your life cycle as a subscriber, right? So they would know when to delete your account because it costs money. Each subscriber is tied to a license or something. Now, the thing about that is it was not normalized. There was a lot of redundancy. And I'm sitting there and I'm asking my boss, why isn't this thing normalized, right? Well, it's a lot easier to report like that, you know, and all those things. But also, you know, when you're working for a rich entity like Celtel, they have the money. They had the money back then. This was 2000 and between 2007 and 2011 is when I was working for Airtel. And at the time, we had access to modern day compute infrastructure. You know, so this server, for instance, which had gigabytes of RAM, right? Back at the time when getting access to a laptop with 1 GB was a big thing. But anyway, so data warehousing, and I'm looking at the time here. I'm going to say when we meet next, which is day after tomorrow, we're going to have a very short discussion about ethics. And our focus is going to be primarily on the Data Protection Act of 2021. For this discussion to make sense as homework, what all of you are going to have to do is you're going to have to go to parliament .gov.zm and get your hands on the Data Protection Act. It's a very short document, Data Protection Act of 2021. It's just 40 pages. Read it so that you understand the lecture. I'm going to pause here and ask if there are questions. I have to be going for some meeting at ICTAS. Are there any thoughts or questions about it? Godfrey, you have your hand up, please. Okay, Godfrey doesn't want to speak. Benaya, do you want to say something? You have your hand up?
Yes,
Okay.
I have a question.
Yeah, please.
Are we supposed to submit the assignment for tomorrow, or you keep track of the things at the end of
what you're
the
supposed to
the
do
project?
is, yeah, great question. No submission. If you notice on the Moodle, there's no provision to submit. But what you should do is the GitHub repository should be created. You should have created them by now because we want to see the commit messages. You must add my email address and Hudson's email address to the GitHub repository. We shall look at the commit messages so that we see if you're doing what we said you should be doing. That's one thing. And then the Jupyter, the Google Colab Jupyter notebook should be shared. So you will do what I normally do here. Observe. You will go to your Jupyter notebook you will go to your notebook like this, and then you will click on share. When you click on share, you shall add my details and Hudson's details here as collaborators. And what we want to see, the reason we're asking that, in case you're wondering, is we will analyze your notebooks to see, right? We are going to analyze them so that we see the changes that have been made to the notebook. Does that answer your question?
Yes, sir. But are we adding you as a user or as an editor?
Please don't add me as an
Viewers,
editor, just add me as a viewer. That's fine. Actually, as an editor, because we'll only be able to see your the version history of your Jupyter notebook if you have permission. So add me as an editor and Hudson as well. All right. And then
all right, sir.
okay, wonderful. Thanks. I see there's a question here. How are we submitting today's assignment? I've already answered this. And then when is the quiz? Mr. Mwani, the quiz is on Thursday, 11 hours. You probably want, if I were you, I would show up on time here. There's nothing like, no, I missed the quiz here. All right. I have to dash now. Thank you very much, everybody. See you day after tomorrow. Bye for now.
Sorry, sir.
Yes, good. Yes.
Do we have Mr. Hudson's email?
Yes, Mr. Hudson, his email address, he was CC'd in the email that I sent through introducing him. But in the event that you want me to share Hudson Mataka's email, I'm going to share it in the info messages right now. You use the same format, is it? It's hudson.mataka@cs.unza.zm. I'm not sure if he uses the same email address for his GitHub account, but you should be able to link his things together. All right. What is the format of the quiz? He says. Just questions based on what we covered in the lecture series associated with the quiz. I didn't actually figure out the format, but because it's 10 minutes here, it's going to be short. You know, just we're going to maybe present you with code, and then you tell us what the output is or something, or we tell you write code that does this or something like that. Simple stuff if you've been following through. All right. Thank you very much, everybody, and I'll see you on Thursday at 11. Bye for now. Yes, there's another question.
Yes, sir.
Like, which
is your GitHub user?
Yeah.
How are we going to add you?
I can't get what you're saying. Come again?
Can you hear me? Hello, sir. Can you get me?
Yeah, I can get you now.
I was saying, what's your GitHub user so that we can add you there as a collaborator?
Oh yeah, it's my email address. lighton.piri@unza.zm. Just add that email address.
Okay.
Yeah, but my user, if you want my GitHub username, it's lightonpiri, one word. But just use my email address. Thank you. All right, bye for now, everybody. See you on Thursday. Thank you.
some related to the topic.